So with this question, okay, a lot of people missed when we discussed this. This was like a topic out of 1.4, okay? And I deliberately said without solving. So because we were doing substitution elimination on the bottom, like you guys could have substituted or eliminated, and you would have gotten no solutions. For the reason, if we look at, and this is kind of what I want to see, if I ask you something like this ever again, you want to discuss the m value and the b value for both equations. Okay, we did this in 1.4. So in this equation, m was 2 over 3, and b was negative 9. And in this one, it's 4 over 6 and negative 3. Now, upon like first glance, you're like, okay, the slopes don't match, y-intercepts don't match, they must cross, right? But if you take a closer look at the slope specifically, okay, what do you notice about them? Yeah, Coco?
They're like the same.
They're the same, they're just twice as big. 4 over 6 is just twice as big as 2 over 3. So they're actually the same slope, right? And the other reasoning is if you were to go onto a graph and you counted the slope for the first one was up 2, 1, 2, right 3, 1, 2, 3, assuming I started from the origin, right? And then I did it again, 1, 2, 1, 2, 3, and I plotted again. There would be my line. Okay, but if I decided to then plot this slope, I would go up 4, 1, 2, 3, 4, and right 6. 1, 2, 3, 4, 5, 6. Can you see how they're the same slope? They're just twice as big. So it's in that instance, I saw somebody write on one of their quizzes, like they had like a little box with all the rules. So that was good. They had summarized like if the slopes are the same and the y-intercepts are different, then the lines are parallel, right? So the issue with this question is like the slopes are the same, okay, but their starting points are different. So one was at negative 3, and the other one would have been at like negative 9, right? But the slopes match. So they're never actually going to cross one another, right? We can come to that conclusion by discussing both of these two pieces. Okay, that's what's important. There's lots of dancing around like slopes are different or y-intercepts are different, but you have to discuss both of them. That's what your determination, you can't make a determination without looking at both of those values in both of those equations. Is that okay? Okay, had those slopes been different, then yes. If it had started at negative 9, the slope was different, yes, they would have crossed somewhere. Okay? At one unique point. If they both started at negative 3, then they would have been the same line. And you would have had infinite. Okay? Okay? Those are your only three options. You got infinite solutions, you have no solutions, or just one, right? Where they cross once. That's it. Okay? That's a little bit of thinking. Okay? Alright. We can take a look at this guy here, okay? Some of you made it a little bit more difficult, so you weren't wrong. Some of you decided, okay, well, I'm going to isolate for x here. Okay, so you went about and you went x is equal to y plus 3, and then you took that piece and you plugged it into the x that was here, and you solved, and you got the right answer, and it was all fine. The thing with this question is it was set up in a way where you have y equals and y equals. Okay, so I'm just going to rewrite this here. This is always, it's interesting because it's the easiest one. You're like, this is the ideal situation, but nobody ever recognizes it and it seems difficult, right? But both of these things are equal to y. Does everybody agree with that statement? So I can just delete the y in the middle and the two equations are equal. 4x minus 9 is equal to x minus 3. And then there's no more y, so you're just going to solve for x. This is just like a linear equation from lesson 1.1, right? So I can move the x over. So I can go 4x minus an x, right? And all I did was subtract an x from both sides. And then these cancel with each other. And I'm going to do the same thing with the 9, but this time with the 9, you guys got to be really, really careful, okay? Because if you make a sign error, you're going to get the wrong point. So you're just going to add 9 to both sides, okay? There was a few people who wrote minus 9, a little sign error, then they got, yeah, Paul, sorry.
What was like the class average?
I could figure that out after. Nobody fails. Nobody failed it. I can figure it out after. It's all on my spreadsheet here. Okay? Again, I was being pretty lenient with the formative so that you guys we can try and build some confidence around what it is you're doing, because there is some good stuff on some of your pages. We just need to perfect the process is all. Right? So if you guys fix the things that we comment on, Mr. Lynn and I, it would be okay. Okay? So some of you just make little sign errors, and now you're going to get minus 12 on the side. You're not going to get the right point of intersection then. Right? So just be careful. You got to add 9 to both sides. Okay, so down here you're going to get negative 3 plus 9. And then so you get 3x is equal to 6. X is equal to 2. Okay. Once you have that, you have half the question. Well, you have half the piece of what you're looking for, right? You're going to take it and plug it in into either of the equations to find y. One of these two equations. Okay? Doesn't matter which one. Just going to plug it in. So y equals x minus 3, let's say. I'll plug in 2 for x. We'll go around the top. Okay. There you go. Then you just state your point of intersection. You can write that right in the box. That's why I put the box there, just to prompt you guys so you don't forget. Okay, you're going to write 2, negative 1. Make sure you include the brackets, because anytime you write a point, that doesn't really mean anything until you go that with the brackets. Okay, now it's a point on a graph. Is that okay? It's a bit of a mixed bag in terms of some people messed up the elimination, some people messed up the substitution. It's always a mix of it. Remember, you're gonna have the opportunity to choose the method that works best for you for the word problems, but I do have to test you on both methods for this test, okay? And you're right, and I did this kind of on purpose, is I would have just substituted x. You already have x by itself here. If I was just solving this just because, I would have plugged this in right there and been done. But this question's forcing you to use the elimination. Okay, so we got to manipulate what's gone on here a little bit. Okay. So I'm interested. I think the easiest one to get rid of is going to be x. Would everybody agree? Okay, I see a 1 here. And I suppose if you really wanted to, just to make things look nice, you could move this over to the other side and rewrite this thing. 1x plus 3y is equal to 1. Okay, all I did was rearrange this equation here. Okay, now the x's and y's line up. x's and the y's, and the numbers all line up. But the problem is, if I were to do some order of operation on this thing at the moment, nothing's going to cancel. That's where I'm stuck, right? So what you're going to have to do is I notice that there's a 4 here. So if I multiply the bottom equation by 4, everything, all 3 pieces, then I can get the 4 to cancel, and like the x's to cancel, sorry. Okay, so why don't we do that? I'm going to take my equation. I'm going to multiply everything by 4. Okay. So I'm going to get 4x plus 12y is equal to, does anybody have what negative 38, oh sorry, never mind. It's times 4 there. Okay, are we good? Now remember, I'm not really looking at this equation anymore. I'm looking at these two. Okay, so I'll rewrite it underneath. Okay, and then all you're going to do is you're going to perform an order of operation, right, to make these guys cancel. 4 minus 4 is 0. So you can get 0x. This is the way I do every time. So I always I look at the sign here. I go positive 12 minus negative 2. Positive 12 minus negative 2. 2 negatives make a plus, right? And so I get positive 12 plus 2. Same thing down here. I'm going to get positive 4 minus negative 38. Positive 4 minus negative 38. So I essentially get 4 plus 38, which is going to equal 42. Right? Now I have 14y is equal to 42. Divide both sides by 14. What's 42 divided by 14? What is it? Is it 3? Okay. Does anybody need this? Can I cut it out here? I'll move it over. Okay, and then all I'm going to do is take that. I'm going to pick the equation that looks easiest to find x. In my case, I think the easiest one is this one, because I'm looking for x. So you just plug y back in there, where it says y, and it's going to spit out x. X is equal to 1 minus 3y. X is equal to 1 minus 3 times 3. X is equal to 1 minus 9. Okay, and then you could write your, sorry, mine jumped down a page, it's down here now, but your point of intersection is negative 8, 3. Is that okay? A little bit nicer on the test this afternoon, okay? I won't make you I'll give you one easy one and then one harder one. And the harder one would just be something that you have to multiply. Okay, so you get kind of one opportunity just to subtract and show me that you know it. And then the second one's going to make you kind of manipulate what goes on. Okay, that's all. Okay? Are we okay? Any questions?